Okay, welcome to Lab 2. Above, you should have seen a link to download a zip file that contains everything you'll need for this week's lab. That's here on my desktop. Also on my desktop is my folder for the GitHub repo for this course. You should have one that starts with your own initials. And I'm just going to open that up so we can see it. And then I'm going to double click the zip file. On a PC it might be slightly different, but it's going to be similar to that. And it should unpack as something called Lab02. And I'm just going to take that and drag that into my labs folder. Make sure it goes in the right spot. Keep everything nice and organized. And then we can get rid of the zip file. So I'm going to drag that to the trash. And then next I'm going to go ahead and commit those changes to GitHub. So I've just pulled up GitHub desktop here on my repo, and you can see there's a couple bits of data, 2 CSV files that we'll be working with for the lab, plus the R Markdown file. So I'm just going to put add lab 2. So I'm going to commit this to master and push origin. And again, a good step is just go to your repo page on github.com and just make sure it's there. So you can see I added lab 2 12 seconds ago. All right, looks good. Okay, next I'm just going to go ahead and open up the Markdown notebook for this. So I'm just going to go into my lab folder, double click on it, and it should pop open RStudio. And there is the file, and here's the folder. If this didn't pop up for you, you might just need to go to your, say, desktop, wherever you keep your GitHub repo, go into your repo, go into labs, and we're in the appropriate folder now. Okay, so the way this notebook is going to work is that you should follow along with me and listen to this video while also having up this Lab 2 Markdown notebook. And as we work through the notebook together, you read down, listen to the video, and there'll be some concepts that I'll explain. Okay, so about this notebook. So in this notebook, we're going to review some of the concepts introduced at the end of class 2. And the things we covered were loading packages, an overview of the Tidyverse suite of packages and its opinionated approach to data analysis, programming with some pre-built functions, specifically those made available by the Tidyverse, and loading some data. So we're going to go over those concepts again. And then some new stuff we didn't get to in class, which includes rearranging columns with what's called a select function, sorting different columns with what's called the arrange function, combining things together in a way to write more efficient programs, and that'll make more sense when we get to it, and then how to debug some problems. So how to work through this notebook. So this notebook contains text and code that I have written, and what you should do is you should read the text that's in this notebook. When you see task set off in blue here with 2 asterisks, that's an indication that you should do one of 2 things as instructed. You should run some code that I have written, or you should write some code of your own and run it, sometimes with a comment I'll ask you to include inside of a code block. So you're listening right now to the accompanying video for this notebook, and you should follow along with the video, pausing it as needed to complete tasks. Throughout the text of this notebook, you'll notice the words details in video, and that's set off in blue with these 2 asterisks on each side at various points. And that tag is an indication that I will demonstrate something in the video that isn't written out in much detail in the text, so that it's extra important to pay attention to that section of the video before moving on. I'll do my best to call out the line numbers I'm on when I talk about something in the video, so that you know you're sort of in the same place. Okay. Submission details. So when you're finished with all these tasks, you should save the file after making the edits. You're going to commit the changes in GitHub Desktop using the process I've showed you, and we'll do that again together at the end. And then push your changes to your repo on github.com. And then lastly, you're going to submit the github.com link to the Elms assignment. Okay, so some of this we went through in class, but I know some people had some technical issues, and so I'll review it again. So our packages are pre-written bundles of code that provide shortcuts, typically through things called functions, to help you do all kinds of things in the data programming universe. Visualizing data, cleaning data, pulling data from Twitter, scraping websites. And you're able to do this with packages with a lot less work than would be required if you wrote them on your own. So one of the great things I love about R is that it's a language, but it's also a community. There are a community of people who work together to create and generally releasing for free all of these great tools they've written, packages, to help other people who are interested in doing the same things do those things more easily. So just a reminder, a couple things. You can load packages directly from what's called CRAN in R, and I'll show you the function to load packages. But they're all stored up on or accessible through a website called CRAN. Right now there's like 16,000 packages. Some of these, I have no idea what they do, but we'll be making use of some of the more popular ones. Here's one, for example, with COVID data that makes it easy to load. In addition to the CRAN repository, there's a website I like called AwesomeR that's highlighted here that you can look at that has links to some, sort of especially useful packages. And some of my favorite packages do very specific things. There's one called Tidy Census that allows you to pull demographic information about different levels of geography in the United States, everything from states to a neighborhood. And there's data from the US Census in there, race data, income data, gender data, age and other demographic data. Lots of interesting information. RTweet is a great package that helps you pull information from Twitter. You could pull the tweets from your favorite athlete and analyze them in some way, or the president. It's kind of a cool package. The opioid data we've been working with from the Post. The Argos data of opioid shipments. The Post released their own package that makes it easy to get access to that data. And then two others that I really like for people who like baseball. This is a package that makes it really easy to pull in statistics from different baseball stats websites. And then a cool one that I didn't show in class, but I added to the list when I was finishing up this lab, is pretty neat. It's called Spotify R, and for those of you who are Spotify fans, it allows you to pull data from Spotify. So like a really neat thing would be you could figure out which key your favorite artist played a lot of their songs in, or look at the most popular artists and how happy their music is. Just a lot of really neat stuff. Okay, so one package, or actually in this case that we'll be making use of, is called the Tidyverse. It's a collection of packages. It's actually called a meta package. It's a package comprised of lots of smaller packages. It's called the Tidyverse, and it makes doing data cleaning, data wrangling, analysis, and visualization easier. This tutorial that we're using here makes use of several Tidyverse packages to load, wrangle, and analyze data. Everything we do in this class, you could do with the base R language, but it would make less sense, I think, and it's a little bit harder and more time consuming. So my recommendation is that if you're using R for data analysis, you really want to be using the specific methods and approaches that are made possible by the Tidyverse family of packages. When we work with R in this class, what we'll generally be working with is the Tidyverse and the specific functions and methods it enables. One note about problem solving, that means when we search for help solving a specific problem on the internet, typing things into Google, as you'll see in this class, when you get an error message or have a problem, it's really useful to search those problems on the web. And adding Tidyverse or R or the name of a specific Tidyverse package and the letter R when you search can be really useful. I want to introduce you just briefly to some help resources. In this class, we are going to form a pretty nice foundation for doing journalistic style data analysis and data journalism. And in some cases, there are ways you can go much deeper using the Tidyverse family of packages, where we'll only be getting so deep. If you ever find yourself wanting to do something maybe a little more advanced or forgetting how to do something and needing to look it up, this collection of resources that I have here on line 79 is pretty useful. So here's the main website for the Tidyverse, which is tidyverse.org. And this is a nice entry point to some of the packages that make up Tidyverse. So, for example, we'll be talking in this class about ggplot2, which is a package all about data visualization. We'll be talking about dplyr. A lot of the core data analysis things we do are, we'll be using this package called dplyr. To load data, we'll be using this package called reader. So each of these packages has their own package page. So this is the page for dplyr, and it's got a list of a lot of the functions that come baked in as part of that. So today we'll be learning about select and arrange, but there's also a lot more that we'll be doing. Each of these sites has a reference page with a list of all of the what are called methods or verbs for doing data analysis. So again, we'll be using arrange, which is how we sort, and select, which is how we pick certain columns, subset certain columns in data. Each of these packages has something like that. There's also a book, a free online book that I really like called R for Data Science by one of the creators of the Tidyverse, named Hadley Wickham and Garrett Grolemund. And it includes a lot of, sort of recipes for how to do data visualization, how to transform data. And it's not journalistic per se. It's more of a general approach to data analysis for a lot of different, industries and use cases. But I find it to be incredibly helpful, and it's a great way to learn. It includes examples. And then lastly, the people who make RStudio have released a series of primers, or like sort of tutorial walkthroughs that will help you learn some basics about R programming and other things. And a lot of that is written using the Tidyverse. So very helpful. Okay, so in the video, we're now at the install packages section. In order to make use of packages, there's two steps, right? So the first is we have to install it. And in R, one of the ways to, probably the most common way to install a package is through a line of code, a function called install.packages. This is a function. We'll see this commonly with functions. It's some word, the name of the function, followed by open paren and close paren. And inside of there, we'll put some information. In this case, the name of the package we want to install. So though there are exceptions to this, you typically need to install a package once. This is the first time you're using a new machine. And you shouldn't have to install a package again unless you want to update it. If you move to a new machine that doesn't have that package, you'll have to install it. So we have reached our first task here, which is to run the code block here to install the tidyverse. So you may have already done this in class. I know some of you had issues. If you already have done it, there's really no harm in reinstalling it. It will just update it, and if there's a new version, it'll add it. Sometimes they issue new releases of these packages when they, come up with a better method for doing something. If you run into errors when you're doing this and you can't get further than installing it, please reach out to me on Elms or a classmate, and I'll help you with that. So let's just go ahead and run this. So I'm going to install it. So again, what's happening here is I'm doing install.packages, and the package I'm installing is the tidyverse. And this is a comment here saying install the tidyverse. And just as a refresher, we're running code here inside of code blocks. In the future, you're not going to have to do this install packages step, but good to know how to do it because we will be installing other packages going forward. Okay, and so we've also hit this details in video. And so if you're working in the text sheet, just a reminder, anytime you see this details in the video, I'm going to go into a little more detail. What's actually happened here when we install this package is it's trying this URL. So the place where the tidyverse package lives is on the internet, and it's going out on the internet to get that package and downloading it and then installing it. So that's this console script we hear. This red, these are messages. Sometimes they're called they're warnings. Sometimes they're errors. But that's what this output is here. Okay, so now I'm at the loading packages heading, and a reminder here that once a package is installed on your system, you're not going to have to load it again unless you want to update it to get new features. But every time we want to make use of a package, we have to load it at the start of a new session. So the way we load packages, there's a couple different ways to do it, but the way we'll do it for the most part is with this function called library, and it loads the package so it's available for use. So you have another task here. Go ahead and run this code block, and now we're going to load the tidyverse. So I'm going to click play. And this is generally what it should look like when the tidyverse loads successfully. Another way we'll know if the tidyverse loaded successfully is when we go to use functions that are enabled by the tidyverse, including today we're going to use something called read CSV to load data. That's from the reader package. We're also going to use a couple different packages from dplyr. If those don't work, often there'll be an error saying, the tidyverse didn't work, and you have to load the tidyverse. And I'm going to show you an example of that a little bit later. But generally speaking, this is what it's going to look like when it loads correctly. We can also see that it's loaded, by the way, by going over to what's called the File Explorer tab and clicking on this Packages tab. So in my system library, it has a list of all packages I have installed on my system. These are all things I've previously downloaded. Most of them don't have this check mark next to them. The check mark is an indication that that data set has been loaded. So for example, when I loaded the tidyverse, it loaded this dplyr package. It also loaded ggplot2 for visualizations. If we scroll all the way down, we can see there's the tidyverse that's been packaged, that has been loaded. So we know the tidyverse is loaded because it has this check mark next to it. You would almost never, not any reason to do this, but just to show you, I could unload the tidyverse by checking this box. And in the console down here, it actually ran a command called detach package tidyverse. If that happens and I try to do something from the tidyverse, it wouldn't work, so I just need to load it again. So I'm just going to load it again there. Okay, so we are now at somewhere around line 119, loading data. So we're going to use a function here from the reader package, which is part of the tidyverse, called readCSV. And we are going to read in data on opioid shipments that we've been using a little bit in class from the Washington Post's release of DEA ARCOS data. So the data we're going to load has a row for each pharmacy in Mingo County, West Virginia. And it's going to list for each of those pharmacies the total number of pills shipped to that pharmacy between 2006 and 2014. It's a column header called total dosage unit, and then the number of shipments, total records. So we have a new task here. You're going to run the code block below to load the data, and then I'll describe it a little bit. So this is a details in video section, so there's some things here I want to go over. So I'm going to run this, and let's look at what happened. So the first is we got this message saying parsed with a column specification, meaning that it was read in. We've got each of the columns from this data set, and it's telling me what the data type is, or what the program guessed was the data type for each one, and I'll talk in a minute about what data types are. In English, here's what this says. There's a comment. The comment is not actually parsed by R, so it's just a helpful bit of line reminding you of what we're doing. So we're creating a new object called ARCOS WV Mingo. This could be anything. I could put Sean here. It doesn't matter what it's called. Just what matters is that we're creating a brand new object, something we can refer to later or do things to later. And we are assigning something to this object, object name, and this is the little assign. It's a less than sign and a dash. What are we assigning to it? We are assigning to it a file called a CSV that's stored inside of our data folder, which is right here. So we are saying use the readCSV function to read in this data and store it as something called ARCOS WV Mingo that we could refer to later. Which is why in our environment window we now have this object called ARCOS WV Mingo. It is 17 observations. Observations is another word for rows in R, of 7 variables, meaning 7 columns. I can click on it and open it up, and it pops up in this sort of handy, almost like a spreadsheet viewer. In R, this, we'd call this a spreadsheet, maybe if we're using Google Sheets or Excel. In R, this is what's called a data frame. Another word that you'll see often in the tidyverse is it's called a tibble, which is a kind of fancy spreadsheet, a way to store data. So there are 7 columns. So each row, 7 columns, 17 rows. Each row is a pharmacy, or in some cases like a doctor's office. For each pharmacy, we know the buyer state and county, which is Mingo, West Virginia. This is only data from Mingo, West Virginia, which is one of the counties that had the highest per capita rate of opioids shipped to it. We've got a unique identifier for each pharmacy. We've got the name of the pharmacy. So this first row refers to something called Stroh-Snyder, which is in a city called Kermit. And we see the total dosage units, which is the number of pills, essentially. So we know that between the period covered by this data, 2006 to 2014, this pharmacy in Kermit, West Virginia, had 13.168 million pills of hydrocodone or oxycodone sent to it. This total records column is the number of shipments. So there were 7,691 discrete shipments of opioids to each of these places, to Stroh-Snyder. This next one had 12,000 shipments, and so on and so on. Okay, so I just want to show you here, the object name could be anything, right? So instead of calling this Arcos West Virginia Mingo, let's say I called it Sean. That's my name. And I ran this. Now we have another object called Sean that essentially has the same bit of information here, right? Same thing, it's just called Sean. Changing the name here didn't get rid of this other data frame. It's still in our environment window. If we ever want to remove data, like I don't want this Sean thing here anymore, to remove everything, I can just click this broom button, and that will, wipe it all out. That doesn't delete the file that's in our data folder that contains this information. It's just gone from the environment. So I'm going to rename this Arcos WV. Arcos WV Mingo. And I'm going to read it back in. Okay, the other thing here is that the folder path matters. So this is essentially what's in quotes here. It's the name of the file that we want to load. This is the data inside of the data folder that I provided to you. But it also serves as directions to where to find that file. So what matters is the starting point. So we're in this lab02.r markdown file, right? That's the file we're in. It's up here. And what we're saying is from this file, go into a folder called data. So I'm going into a folder called data, and then load the file in that folder called Arcos WV Mingo, etc., .csv. If for some reason I got rid of this data folder, right? So what I'm essentially saying is, in the same folder that this lab02.r markdown file is, find the file called Arcos WV Mingo 54059 pharmacy.csv and load that. We're going to get an error. And the error is saying it does not exist in the current working directory. And that is correct. There is no file called that at the same level here. So, I need to give it directions. So I need to say go into the data folder and then load the file. So when I put data and run it, it loads correctly. One other thing I want to show you here, I'm actually going to go ahead and restart R because I want to show you what it looks like when we try and load data using a function from the tidyverse when we haven't loaded the tidyverse. So you can either do this with me or you can just watch, but I want to show you this here. So we're going to go to session and restart R. Okay. And I'm just going to go ahead and clean up the environment. Okay, so we've restarted R. What I have not done is I have not scrolled up to reload the tidyverse. Okay, I haven't reloaded any of the packages that we're going to need for this. And if I look in the package window, we can see, the tidyverse down here is not checked, and neither are any of the packages that load when the tidyverse loads, including the reader package, which is what this read CSV function comes from. So when I run that, we get error in read CSV, could not find function read CSV. Okay, so frequently, as you are going through your work in this class and in the future, if you continue to do data journalism work, and certainly I hope you do, you're going to get errors. Everybody gets errors. Errors are not an indication that you are bad at this, or you're screwing this up, or you're doing this wrong. They are just a natural part of it. We use the errors as information to figure out how to fix a problem with code. And the best way to do that is Google. So I'm going to copy this. I'm going to go over to Google, and I'm going to type in could not find function read CSV. And remember, I told you that I think it's generally a good idea to like add tidyverse R onto it. Okay. So we come up with a list of Google results. So one of the first ones is from how to deal with error could not find function read CSV. This is from a website called Stack Overflow, which if you're ever going to do any kind of programming work is your best friend. So Stack Overflow is a place where people are having problems and they ask questions, and other people, out of the kindness of their hearts, go in and answer those things. It's a small miracle. I don't even know how I would do any of this programming work without Stack Overflow. So 2 years and 5 months ago, this user asked this question, installed the package reader and tried to upload a CSV file. When I try to load the package, I get the following error. Okay, it says to install a package called reader. All right, for me, I don't know that that's a tremendous amount of help. Here's another website called Community, the RStudio community. Somebody asked a question. This is kind of like a Stack Overflow, but just for R. I'm trying to use the read CSV file to read a CSV file, but I keep getting the error below. Could not find function read CSV. Hey, that's the same error we got. And this person, I don't even know how you say that name, said readcs.csv is the base function, read_CSV is in reader package, and so in tidyverse. Did you load these libraries? Oh, okay, all right. Here's maybe a way we can fix it. Let's make sure I've loaded the tidyverse. So we're going to come back. We're going to scroll up to our section of code where we load the tidyverse again. Don't have to install it again, we just have to load it. And now we scroll down, run this again, and it worked. So a lot of problems when you get a can't find function error, that's often because you haven't loaded the package that makes available that function. But more to the point of that exercise was to show you how to go out on the internet and find help. You can also ask me, you can also ask your classmates, but that's a good place to start. Okay, so we're gonna keep going here. We've loaded the data. There it is. If you couldn't see the name, by the way, if you hover over this line in the environment window and just slide it back and forth, click and slide, it's easier to see. I've also provided you with some links here to places you can go to if you're having trouble remembering how to do something when you're reading in data. There's the link to the tidyverse reader page. So remember, I said each of these packages had a place you can go to get help. Here's a list of all the functions in Reader. So here's how you read in different kinds of files. And then there's also like a lot of example code, for example, with each of these. So here's the specific code for read CSV. Here's some examples of people reading in data that might be helpful to you. There's also these cheat sheets, which the more you work in this, I find to be pretty useful. That'll have some specific details. It tries to lay out lots of different things you can do with the package. And I generally find these to be pretty helpful. Okay, so now we are have reached the point where there's a task you're going to do on your own. In the data folder, so I'm going to go back to files here, I have provided you a data set that is very similar to the data that we have already loaded for Mingo, West Virginia. But in this case, what we have is Baltimore City data. And so this file is called Arcos MD Baltimore City 24510. So I've created a code block for you here, and here's what I want you to do. I want you to create an object called Arcos MD Baltimore City. So I'll just paste that in here for you. And I want you to finish out the code here to read in that file. All right. So the code you're going to write is going to look pretty similar to what we did above to read in the Mingo data. So I'm just going to pause here for a second, and I would ask you to pause the video while you figure out how to write this. And if you get stuck, maybe just scroll up and look at that there. So go ahead and successfully get the data loaded in, and then it should pop up in the environment window when you do that. So go ahead and pause. I'll wait just another minute here, and then we'll go over how to do it together. Okay, so first is we've got the name of the object. So this is what we're creating. And then we've got this little less than sign and a hyphen, which is how we're going to assign the file that we're reading into this object, how we'll refer to it later. So we're going to write a function called read_CSV. One cool thing, by the way, when you're typing out functions in R is when you start to type something that it exists as part of a package, you get this syntax completion box. And in addition to telling you the name of the function in case you forgot it, it will also tell you what the arguments or specific things you can do to put inside the function. So at a minimum, when we're writing this read CSV function, we need to feed it a file name. So the file name is, so if you remember correctly, right, we go into the data folder, so data, and then here's the name of the file. One handy way, so we don't have to type this whole thing out, if you want to get the name, is click this box, click rename, come up here, copy this whole thing with Command C, and then we're not going to rename it, so just hit cancel, and then we can paste it in. So when I read it in, there it is. So what do we see here? We see 317 observations, 317 rows of 7 variables. One common mistake you might have made, maybe you just typed the name, you forgot to put the data folder. When you run that, remember you get the does not exist in the current working directory because there is no Baltimore file in this folder. So data/read it in. And just briefly, we'll just go ahead and look at it here. We've got the same columns as we had with the Mingo, West Virginia file. Just more pharmacies. Baltimore's a bigger place, right? Okay, so now we're going to go over, and we're at about line 150, how to examine data that we've loaded in. So once you've loaded in some data, before you sort of launch into analysis, it's a good idea to get a general overview of what's in it, what the column names mean, what each row means, if there are like things that look weird, like missing data. And there are 3 ways that I like to do at the top just to get a sense of what's going on. So a couple different methods. We're going to go through each of those in turn. So option 1 is a special function called glimpse, and this function is I think pretty useful to get a sense of the data. I'm just going to go ahead and run it here, and then I'll explain to you what we're looking at. So I've got a code block. I've got the name of my West Virginia data frame, and then I'm putting that inside of this function called glimpse. So when I press play, what happens? We get a sample of what's in the data. So, it tells me it's got 17 rows, it's got 7 columns. Each of these is a column, so it's got the name of the column. On the other side here, it's got like the first few values from the row, so like just a sample, so you can kind of get a sense of what might be in each column, right? So we know Bexar County is Mingo. Here's the buyer name, has the name of these pharmacies. And then lastly, we see the data types for each column. This is how, when the data was read in, behind the scenes, R is storing the data. So CHR is short for character. And generally speaking, when we have columns with text in it, that's going to be stored as a character. Often this will be called like strings. But this is, generally speaking, not stuff we can do math to. So most text will be stored as character. Numbers, if it is successfully read in, will be stored in a variety of different formats, including decimal numbers or integers. This is a format of a number called a double. And the important thing here is that this is actually stored in a numeric format, so we can do math to it later if we wanted to calculate the average dosage unit or sum up all of the pills sent to Mingo to get a total. We can do that because it's math. So that's Glimpse. So in the code block below, what I'd like you to do is go ahead and write a function to glimpse the Baltimore data, just to get a sense of it. And if you want to pause the video, I'll wait just a second here, and then I'll go over how to do it. Okay, so pretty simple here. We're just going to write glimpse, and notice that it started to fill out the name of the function. A little helpful reminder. The thing I want to glimpse is Arcos MD Baltimore City. And usually it should fill in the name, but in this case it's not doing that. Ah, do we see why it didn't find it here? Because I misspelled Arcos. When I read it in above, I read it in as Acros. When it's not found, this is an error you're going to see pretty frequently. Object not found. Often that's because you've messed up the spelling. So to fix this, I'm actually going to go above. I'm going to find where I read in Arcos MD Baltimore City. Maybe you did this right. And I'm just going to fix that there. And I'm going to run it again. Now we have this 2 copies of it. So let's just say I wanted to get rid of one of these. If I click this button that says list here in the environment window, sorry, change this to grid, and then select the one that's misspelled, now I can just remove this one single object, and now it's gone. And I'm going to change this back to list. Okay, so now I'm going to scroll down. So now when I start typing Arcos MD Baltimore City, if I just hit enter while that's highlighted, it'll fill it out. So I can hit play, and looks pretty similar, right? Okay. The other thing we can do is just display the data inside of the Markdown document. If we had an especially large data set, it's only going to display a portion of it. So I'm going to run the code here, and then I'll explain, and I'd like you to do that along with me. So just go ahead and press the play button. And all I've done in this block, by the way, is write out the name of the West Virginia data frame, Arcos WV Mingo. And below, it prints out the first 10 out of 17 rows. And on my screen, I can see the first 3 columns. If I want to see more columns, I could cycle to the right to see the rest. If I want to see the rest of the rows, I can hit this next button. This is a little bit clunky, but it's you know, a way you can also get a sense of your data. So in the code block below, what I'd like you to do is just take a stab at printing out or displaying the Baltimore data here. I'll just pause for a second, and then we'll do it together. So what we're going to write here is Arcos MD Baltimore City, and this code completion is kind of nice. I can just hit enter, press play, and there's the whole data set for Baltimore. If this was more than 1,000 rows, you would not be able to see more than 1,000 rows. So you're limited this way. The last thing we're going to do is we can click on the object name in the environment window and interact with it. So we've done this a couple times already, but just to show you how this works, if we just wanted to click on MD Baltimore, it comes up and we can scan through all the columns. We can scan down all of the rows. There's some advanced stuff that we'll go over later, but it's possible to, you know, sort the data, do some filtering, and we'll get into those in later labs. Okay, so we're now at about line 209. Some of the row numbers may, or the code numbers here may be off by 1 or 2 from the document you're working in, but we're about there. So we're in the selecting data heading. One of the most basic things we can do with a data set we've read into R, a data frame, is to select certain columns. That is, we have a data frame that has, say, 7 columns. We can hide some, we can reorder them to put one column in front of another column. On its own, let me just say, selecting I don't find to be tremendously important as like an end product to answering a specific question. In the same way, when we get lower in the document, we'll see that sorting really is something that can help us. But selecting is a foundational thing that we're going to use over and over again in concert with other methods to help us answer questions. So I think it's important to kind of know, and it's also a very basic thing that will help us just get started. So there's a 2-line chunk of code below right here that what it's doing is it's going to take our Mingo data frame, which has, and I'll just show this to you here, has 7 columns, right? One of those columns is a column called buyer name, okay? And it has the name of the pharmacy in it. And so what the code here is going to do is it's going to basically pick out the buyer name column and get rid of everything else and display it in the Markdown document. So I'm going to run this code block. I'd like you to run along with me, and then we'll talk about what's happening here. Okay. So, you know, before I could click an arrow button here to cycle through, and there was the names, there were additional columns. In this case, all that exists here is this one column, buyer name, for all 17 rows. Why might you do this? It might be useful just to have a list on its own of all the pharmacies in one county. If you were, you know, making a list to make calls to all of them or something. What is happening here in English? How do we explain what's happening here? What's happening here is we're saying take the Arcos WV Mingo data frame, that's this here. And then what we have here is a little special bit of code that by the end of this class you will have written thousands of times, and it looks kind of terrifying. It's the percent and then a greater than sign and the percent. And in the lingo of the tidyverse, this is what's called a pipe. And anytime you see the pipe, what I want you to think is the words and then. So what this says in English is take the Arcos WV Mingo data frame and then select only the name of the column that I put inside of this. So select is a function, and it's saying pick out the buyer name column. And because I haven't said pick any other columns, just keep that one. A couple notes here. The first is, all this did is this printed this out below the data frame. It didn't edit the original data. you know, imagine you were in a spreadsheet, say like Google Sheets, and you had a sheet, and I told you, you know, delete all of the columns except for this one. You know, you might be editing the original sheet. The original data here is not changed in any way. It's still here. If I want to pop that up, we've still got all 7 columns and all 17 rows. What it's done is just limited to what's happened here in this one block. One other thing I want to show you here too is kind of what an error might look like. So let's say you, instead of writing buyer name, and when I type this out, right, B-U-Y, it's smart enough to pop out the names of the column. So it's got this little pink rectangle. It's kind of tilted sideways. That's a column name. So buyer underscore name. But let's say we misspelled that. Let's say we did B-Y-E-R underscore name and ran that. We'll get an error. Column buyer name doesn't exist. And I guarantee you, no matter how long you do this, there'll be times when you like, well, look at this and swear up and down, yes, it does exist. I did this. I did it right. And what's happened is you misspelled it. So we can fix that just by pressing play. Okay. So the select function, there's a lot more things we can do with it, and we'll get into those in a second. But it is, it's a key part of a lot of the code we're going to write this semester. You know, we may have a mammoth data set with like hundreds of columns. To make our life easier, we only want to work with 4 or 5. We'll just create a smaller data set that only has that in it, only those 5 columns. So we'll be making a lot of use of select, and we'll be combining it with lots of other things we'll do. Select comes from what's called the dplyr package, and there's some resources here that you can get help with the dplyr package. So there, of course, there's the reference page, and there's a list of what are called verbs. You know, if you note, like a lot of these function names are actually, you know, they're verbs. They're doing something to our data. So right now we're selecting, but we'll also be doing things like sorting and creating new columns, and all of those are part of the dplyr package. There's also a handy cheat sheet, just like there was for the reader package that I showed you, that gives you a sort of visual look at what some of the things do. So, for example, here's select, and you can see, you know, it's trying to show you have this table of like 3 columns, and it allows you to pick out, say, just like 1 column. And then another thing about tidyverse pipes, in case, you know, my explanation isn't great, you know, again, what we're saying here with the pipe, the %% is, or % greater than % is, and then. Take this and then do this. The R for Data Science book has kind of a fun little exercise on what pipes are, and uses like a children's story to help tell it. I find it to be quite good, so something that could help you there. Okay, so in the above example, we basically just selected this data and printed it out, but we didn't, you know, change the underlying data or create a new object. And I want to show you what it's going to look like in which we basically select out, say, a limited number of columns, and then store that as a new object we can use later. So let's go ahead and run this code below, run it along with me. And I'm at the selecting data and storing it as a new object section. So what you're going to do here is just go ahead and hit play, and then I'll explain in English what's happening here. So what I've said is create this brand new object called Arcos WEV Mingo Pharmacies. And what are we going to assign to it? We are going to assign to it, first we're going to take the Arcos WEV Mingo data frame. So that's this 17 rows of 7 variables. That's this spreadsheet, right? And then select out just that one buyer name column. So we're saying take the Arcos WV Mingo data frame, our main data set we've been working with, and then select keep only the buyer name column. And then lastly, take the product of that, the result of that, and store it as this thing we can refer to later called Arcos WV Mingo Pharmacies. Which is why if we go to our environment window here now, we have this new thing, right? It's called Arcos WV Mingo Pharmacies. And what is it? It is a data frame with 17 observations or rows, but it's only got one variable instead of 7 variables. Our original data had 7. This one only has 1. We've selected a single column called buyer name, and that's what has the name of the pharmacy. And we can see that if I click on it, we have this 1 column data set here, right? Just the names of the pharmacies. And just to be clear, what it's not, by saving this new object, again, I haven't edited this original data. That still exists. I can still look at it, right? I'll show you down below what happens when you overwrite an object by assigning something to the same name of something you have already loaded. Okay, so now we've reached a section where you are going to run some code. So you're going to take the Baltimore data you loaded above, and remember it's called Arcos MD Baltimore City. And what I want you to do is what it says here on the page, right? Create a new object called Arcos MD Baltimore City Pharmacies. It takes the raw Baltimore data and selects only the buyer name column. So we're going to create a new object called Arcos MD Baltimore City Pharmacies. And what's going to be in that object? Well, what's going to be in that object is you're going to take your original Baltimore data and select only the buyer name column. So we should have, if you do this right, one more data frame here. So I'm going to pause for a second while you do that, and then we'll move on. Okay, so we've got this new object we're creating called Arcos MD Baltimore City Pharmacies. And we're going to assign something to that. And the thing we're assigning to that is we're going to start with our Arcos MD Baltimore City data frame. And then, which is the pipe, select just the one column we care about, which is buyer underscore name. And when we run this, we now have a new data frame up here called Arcos MD Baltimore City Pharmacies. If I hover over this for a second, by the way, I can see the full name in addition to sliding it back and forth. And instead of it being 317 observations of 7 variables, 317 rows of 7 columns, I now have 317 observations or rows of 1 variable. And when I look in that, all I have is a list of all the pharmacies in Baltimore City, but not any of the other data. A note, the original data is still there. It's still preserved. I haven't changed that. Okay, I'm just going to close some of these down. Okay. We're going to move on. We're now at about line 268, which is selecting more than one column at a time and rearranging. Before I showed you how to select one column at a time. The order in which we list the column names when we're selecting more than one column determines the order in which they're going to display. So I've got some code here that I want you to run along with me. And I'm going to run it, and then I'll explain what it's doing. So what we're doing is we've created a new column called Arcos WV Mingo Trimmed. Could assign any name to this, doesn't matter. This is the name I picked. What is in there? Well, we start with our original Arcos WV Mingo data, and then we are going to select the following 5 columns in this order. So I'm selecting the buyer DEA number, the buyer name, the buyer city, total dosage unit, and total records. I'm just going to show you our original data. This is what it looks like, right? So those 5 columns I just named are buyer DEA number, buyer name, buyer city, total dosage unit, total records. There are 2 additional columns at the front that I haven't included in my list, right? There is no buyer state or buyer county here. So here's our trimmed. And notice it only has those 5 columns. The other 2 are missing. So the order in which these appear are meaningful. The order I listed them out are the same order they appeared in the final data frame we created. So I've got some other code here, and it's fundamentally, it's almost identical to the code we just ran above. The only difference is that what I've done here is I put the name of the buyer first and the buyer DEA number second. Above, it was the other way around. Buyer DEA number was there, and buyer name was after it. Okay. Before I run this, I want to show you that this object name that we are that I'm assigning the product of what's being done here, which is take the Arcos WV Mingo data frame, select only these columns in this order. I'm assigning it to something called Arcos WV Mingo trimmed. If you recall, that was the name of the object we just created above. There it is in our data environment, right? There it is above, and it's got buyer DEA number first and buyer name second. When I run this code, because this name already existed in our environment, it's just going to overwrite that. So anytime you are saving something by a name that already exists in your environment, it's going to overwrite it. That's an important thing to remember. So I'm going to press play, and before I do that, I want you to pay attention to what's happening up here. I've got these 5 data frames, right? Running this is not going to add one more to this list. I'm still going to have 5. When I click on Arcos WV Mingo trimmed, it's changed. I've got the buyer name first and the buyer DEA number there. So 2 takeaways there. One is that when you overwrite an object name, it overwrites whatever was previously stored with it. And the other is the order of these things matter. There's a lot more we can do with select. You don't have to do this along with me, but I do want to show you sort of one way that we could achieve the same results as this, but using a slightly different method. So I'm just going to create a new code block, and I'm going to call this Arcos WV Mingo trimmed new. And instead of affirmatively saying, please give me these 5 columns, what I'm going to say is, from that original data set, don't give me 2 columns. So this column called buyer state. So I'm saying, don't give me buyer state. I started with a minus sign. And then I also don't want buyer county. So I'm going to say, don't give me, with a minus sign, buyer county. And in that case, what's happening there is it gives me, it's the same result basically. I've got the 5 columns, but instead of affirmatively saying keep these 5, I'm doing it a different way. I'm saying don't give me these 2 columns. So it's just another method you can use. So I'm just going to go ahead and delete that. Okay, so before we finish with select, I want you to, in the empty code block below, I want you to create a new object called Arcos WV Baltimore City trimmed, and I want you to assign to it the the last 5 columns in the Baltimore data, similar to what we did above. So we're going to, I'm going to pause here for a second. And while you do that, go ahead and hit pause. And when you're ready to go, I'm going to go ahead and start again. So we're going to create this object called Arcos WV Baltimore City Trimmed. So that's the name of the object. So what's going in there? What are we going to assign to that name that we can refer to later? Well, we're going to start with the Arcos MD Baltimore City, our raw original data. And then we are going to select 5 columns. So buyer name, buyer DEA number. What else do we got? Buyer city, total dosage unit, and total records, which is the number of shipments. And when I run that, we now have this new thing called Arcos MD Baltimore City Trimmed, and it's got the 5 values, 5 columns that we want for each row. Okay, we're now at about line 312, and we're going to go over sorting. So selecting things on its own really hasn't, been entirely useful in helping us to answer questions. Down the road, we'll see that it's important to be able to select certain things and not select certain things. It's a key part of, pretty much most, data code we'll be writing, but on its own, it's not super helpful. There is another common method, which we'll call sorting, which is a really important way to help us answer questions, general questions like which one's the biggest or which one's the smallest. And in the tidyverse, the way we sort is with a function called arrange. And so the code that we're going to run below together essentially is a way of answering this question. Which pharmacy in Mingo, West Virginia had the smallest number of pills sent to it between 2006 and 2014? By pills, we mean hydrocodone and oxycodone. So let's go ahead and run this code block below, and then we'll examine it together in the environment window. So we now have this new data frame called Arcos WV Mingo Sorted. So we created this new object. It's now over here. And what have we done? We've said, take the data frame we just created above, which was the 5-column version of our raw Mingo data, and then arrange it. Arrange is another word for sort, on the column called total dosage unit from lowest to highest. So when I click on sorted here, we'll see that the data has been reordered, and you can actually see here, right, that the smallest value, David Nielsen, is at the top, and the largest value, Stroh-Snyder, is at the bottom. So we have reordered this data. So the arrange function is also a part of the dplyr package, and just like above with select, I've given you links to several different reference guides that can help you if you get stuck on arrange in the future. By default, the arrange function sorts the column name that you feed it from the lowest to the highest value. If it's a number column, as in the code we just ran above, that means it's going to sort from lowest to highest, as we just saw here, or what's called ascending order. Okay. If it's a text column, then that means it's going to sort alphabetically from A to Z, and we can see an example of that in the code we're going to run here. So just a note, what's happening here in this code. We're taking the object called Arcos WV Mingo sorted. That already exists in our environment, so what we're doing here is going to overwrite what we've previously done. So we're taking the Arcos WV Mingo trimmed data set, and then we are arranging it from lowest, the letter A, to highest, the letter Z, on the buyer name or the name of the pharmacy. And so when we run that and open it up, we can see it's now in alphabetical order. So Adkins is at the top, all the way down to Tug Valley at the bottom. We can also sort from lowest to highest by putting another function within or nested within our arrange function. And this function is DESC, which is short for descending. And descending simply means sorting from highest to lowest. So it's the opposite of ascending, basically. So the code block below that we're going to run together allows us to find the answer to the question, which pharmacy in Mingo, West Virginia had the most pills sent to it between 2006 and 2014? So I'm going to run this. We're going to look at it together. And again, you know, I've used the same name we've used for the last three functions. So this is simply overwritten what we did previously. So I'm going to pop it up here. And now you see it's sorted on dosage unit, right? So this Stroh-Snyder store in Kermit is highest, all the way down to David Nielsen, the lowest. So as a way of making sense of this function, here's what's happening here. So we're saying take our trimmed 5-column Mingo data set, and then sort it. That's what the arrange function does, by total dosage unit. And because total dosage unit is wrapped inside of another function called DESC, it's saying sort it from highest to lowest. Okay, so now it's your turn. What I'd like you to do is to write some code to answer this question. Which pharmacy in Baltimore City had the most pills sent to it between 2006 and 2014? So just go ahead and put a little comment here to put the answer. And then I also want you to write out the code that you'll need to do that. And I'm going to go ahead and pause for a little bit here while you do that. And you can pause the video. And then we'll come back and we'll show how to do it together. So go ahead and work on that right now. Okay, so we are going to start with our Arcos MD Baltimore City trimmed. And we're going to create a new object called Arcos MD Baltimore City sorted. And to that we're going to assign Arcos MD Baltimore City trimmed, which we'll take, and then arrange DESC on total dosage unit. And we'll run that. And it cannot find Arcos MD Baltimore City trimmed. Oh, does anybody see why? Okay, so above I created an object when I did this above called Arcos WV Baltimore City trimmed. So just an example of a screw up on my part. So I'm going to scroll up in the code to where we created that object. And I'm going to fix it and rerun it. And then I'm going to scroll back down and rerun this line of code, and it worked. So now we have Arcos MD Baltimore City trimmed, and Arcos MD Baltimore City sorted. And we can see at the top, now that we've sorted this in order from highest to lowest, the answer is New Care Home Health Services. Okay, we are almost finished going through the lab portion, and then there'll be a couple exercises for you to do. It's also possible to combine different types of methods in a single code block. Above, we selected some columns and then saved that as a new data frame, and then we moved on to sorting after that. And we did this in separate steps, right? But frankly, there's no reason we have to do it that way. The beauty of the tidyverse pipe is we can chain together both of those steps into one line of code using the pipe symbol. So the function below that we see here in English essentially says we're going to create a new object and we're going to call it Arcos WV Mingo trimmed sorted, right? It's going to combine everything we've done. So we'll start with the original Arcos Mingo data, and then we will select 5 columns we care about, and only those 5 columns, and then we'll sort it from highest to lowest on total dosage unit. So we can run that all at once, and it does it all inside of one step. So again, we take the Arcos WV Mingo data frame, and then we select the columns that we want, and then we sort it. And ultimately, we have this thing called Arcos WV Mingo trimmed sorted, and it's got the 5 columns we want, and it's ordered from highest to lowest on the number of pills. Okay, so that completes sort of my portion of the lab where I'm going to be walking you through stuff. What we have here at the end are 2 exercise questions that I'm not going to work through with you. You're going to do these on your own. So I want you to answer the questions below by writing code in the empty code block. And that code is going to lead you to an answer that you're going to just write out the answer to by editing this comment line here above where you've written the code. So the 2 questions are, in Baltimore City, which pharmacy got the most shipments between 2006 and 2014? And I want you to tell me how many shipments it got. And just a reminder, the total records column is the column in our data that reflects the number of shipments. And then the next question is, in Baltimore City, which pharmacy got the smallest number of pills between 2006 and 2014? And I want you to tell me how many pills it got. And again, just a reminder, the total dosage unit column reflects the number of pills. So you're going to answer both those questions. You can go ahead and pause the video here while you answer them. And then I'll show you what to do when you're done. Okay, so we are now at line right around 425. We're presuming that you are all finished. You've answered the questions. So what you're going to do when you're done that is save your file in RStudio. So just a reminder with RStudio, if this is red with an asterisk next to it, that is a sign that there's some unsaved changes. So I'm just going to, you can go to File, Save, or you can just do Command S to save it. Then I'm going to come back to GitHub Desktop. And you can see all of the changes you've made to Lab 2. So I'm just going to write updating Lab 2 and commit that to master. And then I'm going to push those changes up to github.com. And now when I come to github.com and I go to my repo, we can see that the lab was changed 16 seconds ago. I'm going to go to lab 2, and then this is the URL that I'm going to go to the assignment on Elms to submit. So once you've submitted this link on Elms, you're done. Thank you very much. And if you have any questions about the lab, feel free to ask me in class on Tuesday, or you can reach out in advance. Thank you very much.